what happens is that we have the definition of parking space, which is just one small parking space, and then a whole parking lot, which comprises of many parking spaces, and then also the parking lot group, which can comprise of many parking lots. So with this, we have created evaluations, and how we define it in the parking lot window is that previously it was called the group. This was for the dynamic assignment previously, but right now we have changed it to evaluation group for parking lots for the parking evaluation, and for destination group is still under dynamic assignment. So this is the differentiation now. So for the evaluation for parking, then it's under evaluation groups. For dynamic assignment destination group, we have renamed it to this so that it's clearer and easier and there's no confusion. And as you can see here, under parking lots, there's also under the window list, the new attribute called evaluation groups. And with the parking evaluations, of course, then the new evaluations are again for the different parking spaces, the parking lots, parking lot groups, and even parking routing decisions. And also we have new parking states which are waiting for free parking space, driving to parking space, block while leaving parking space, and going back to route, and even when the parking request is declined. So this, during the simulation, you can have better knowledge of what's happening with the parking vehicles and evaluations as well. So for the parking evaluations, what are the new attributes? So for the new parking spaces, lots and lot groups, you have the example number of vehicles entering, occupancy duration, parking duration, and even which when the parking space is blocked duration. And then for the parking routing decision, then you have the number of parking requests and then how many times it gets declined. So these are quite a few added attributes that you can explore as well in Vision 21 for the parking evaluations. And again, as usual, when we have parking evaluations, we always have this graphical analysis to show basically over here also classification based on spaces, lot and lot groups as well. And what you can see here is then we have activated the occupancy rate of each and every of the parking lots. And then you can group them based on also parking lot groups, where then you can have the different parking lots under the different groups as well. So a little bit about, again, the graphical scheme for the new parking states. So as you can see here, when it is moving back to the static route, and this car, when it's being blocked, when it's trying to reverse out. So this, again, the extension of the parking evaluation in Vision 2021. So as mentioned, with the attribute modification, this is really quite an interesting add-on. So now attribute modification sets a specific attribute of some or all objects of a specific type to a value calculated by formula. So, and another important thing, it is so possible now to access the old values and perform cumulative calculation. And because of attribute modifications, we changed the menu entry scripts into actions. So previously in 2020 and before, it is under scripts, and then you have the event-based scripts and things like that. So under 2021 now, there is also, of course, still the event-based scripts, but we have renamed it under actions. Then we have the attribute modifications and also event-based scripts as well. So these are the different things and options under actions as well. So this is one of the example we have in Vision 21 right now, where we can change the different bar, the RAM bar states by when the signal changes. And then a little bit about the window of attribute modifications, quite similar to event-based scripts. So you can say that from when to when this attribute modification is active and how often, meaning in how many simulation time period, is it one-to-one or every 2 simulation time, things like that as well. And then you can also have the execution time at the time start, and then the object type and the target attribute. So this again, is a very interesting add-on. And right now, let me show you a little bit of the demo of attribute modifications. Okay, so over here, we have quite a simple model. What's happening here is just a static routing going from left to right, and then for the parking routing going over here. So we have 100% parking occupancy. And then, as you can see over here, there's the new parking states in VISIM 2021. So what has been set up in the model is user-defined attributes, which is quite simple. It is just a time back, and it's just a data UDA, and basically it's empty usually unless we want to change it. So how do we modify it during the simulation? As mentioned, it's not under scripts here, so it's under actions, and then you can go under attribute modifications. And over here, I then want to add an attribute modification of saying that, okay, I want to calculate the time it takes for each vehicle to go from leaving the parking spaces they're at and then going back to the route. How do I do that? Is then over here, I add the attribute modification. And here, as mentioned, from time to time, I say from 0 seconds to the maximum simulation time I want it to be active. And then the period is 1 to 1, which is every simulation time step. And then at time step start, for object type, it will be for vehicles in network. And then the target attribute will be the new UDA created, which is an empty one, just a data UDA that I want to fill up. So I say I want to basically modify this particular attribute. And for the new attribute calculated as, what happens is that I want to create that time back plus 0.1. What does this mean is that when the vehicles are then leaving and then going back to the route, then the simulation time starts, the timing starts ticking. And why is 0.1 is because my model is set up to 10 simulation time steps per second. So then every simulation time step is plus 0.1. And for the object filter, of course, under attribute modifications, this is not always necessary. But then because for my object filter, I want it not only to calculate for every single vehicle that comes into the network or anything, but only the vehicles that are going back to route. So how do I do that? Is then I click on here and I select parking state. And I say equals to, I'm not sure which number this falls under, what's the enumerator. So for now, I just put it as 1 first. Then I click OK. And this is where it's interesting, where you can see how it ties very, very close to the event-based script and the COM in VISIM. So I want to know the parking state enumerator, and I click enter. And then looking for parking state, I see that, okay, what I'm interested in is the parking state that are going back to route. So only number 6, not the rest, but only number 6. So then I will go back into, can you see this? Yeah, I don't think, sorry. Yeah. So can you see the COM help over here, right? Am I sharing the right screen? Hello? Okay. So yeah, as mentioned, looking for the parking state, I just want to see the ones that are going back to route. So then only number 6 here. So the rest, I don't care, only number 6 I want to filter for. And then I go back into VISIM. And then I click on this again, and I say that my parking state, I want to be the ones that are looking for the ones going back to route. So I put number 6. And then I click OK. And again, I play the simulation now. So as you can see, the vehicles are driving based on their parking states over here. So these ones are driving to the parking space right now. Sorry. And then, as you can see, for the time back attribute is not modified because none of them are going back to route just yet. And only when the vehicle is leaving and then going back to the main route here, you can see that the time starts ticking. And what happens is, if I also slow it down a little bit over here, when it changes from back to route to none, then this time stops ticking. So we have this sort of time back time timing that for each and every vehicle. So this is basically what I wanted. So as mentioned, attribute modifications is very, very useful. It's a very good bridge into not having to script in Python or know any programming language, but actually just be a bit familiar with the formulas that you have used for, let's say, under UDAs or formula routes. And similarly, you can use for attribute modifications to change it back. But of course, scripts still have the advantage because at certain points where, example, you want to add or remove objects, or you want to add a pedestrian exactly at a certain spot. So these are still controlled by scripts, but many things now can be done straight away under attribute modification. So once that is done, I go back to the slide. And as mentioned, the OpenDrive improvements for driving simulator interface, now we support the version above 1.4. And then of course, 1.5 and 1.6 can sometimes as well be imported. And then there is the improvement of lane widths. So when there is a different lane configuration changing, where the lane widths are changing across a link, what happens now is that the import will then import it as connectors and links as well. And then the connectors are the ones that are expanding. And also there is the import of the Z coordinates. So for the OpenDrive as well. And then as well, there is COM access for the import OpenDrive functionality. So this, again, another improvement where instead of having to modify a lot in Vissim after you import OpenDrive from, example, some other simulator software, you straight away can import that particular network and run your simulation and then have the co-simulation platform with another software. And other improvements for the driving simulator interface, where the co-simulation with Vissim can now add or remove vehicles to and from the network at any time during the simulation as well. And then the simulator can take control over normal Vissim vehicles and then give it back to Vissim at any time during the simulation as well. And there is a new custom lane change behavior for now. It is still under this part where you have to create a UDA and then have the exact name and then use it for free distribution. It's not directly as a attribute straight away, but if, let's say, we see a lot of usage for this, then of course we will put it under the default under the driving behavior. So this allows for smoother lane changes compared to the more rougher one in Vissim. So what you can do is change it based on the different vehicles as well. So this allows for more flexibility when you want to create a smoother lane change. So the difference over here is then, as you see, the smoother ones will go here, whereas previously for Vissim, it's the white line over here. So these are the differences you can change under the driving behavior and create the new UDAs now. And the functionality of 3D buildings, previously in Vissim 2020, this was radio functionality, but now what you can do is show and hide the 3D buildings. So this allows more flexibility where you can control and click on a few that you want to hide, or maybe just a whole area that you want to hide, and then straight away you can make it visible, invisible, And another thing to note is that if you have a static 3D model, if you hover over it, it will straight away disappear so that there's no overlapping. And again, there's a multi-run video and animation recording. So video and animation recording is of course the old functionality, but now there is this recording scope. So previously it was only the first run, whereas now you can have the recording scope for every single run, the first run only or the final run only. And this again also like another extension of current functionality. AVI recording previously was only in 3-dimensional, where you are not able to see all these bars very clearly, but right now you can with the 2-dimensional AVI recording. And of course, every year we try to speed up the simulation for Visum and Vism and Viswalk, and then this year there's an improvement of 5 to 15% of simulation speed gain for bigger networks, and even speed up to 25% as possible. And this is a new, very new feature, not feature, but an extension that actually is not included in Vism yet, but it is something interesting that we are looking into, which is the AR for Vism. And do let us know if you have more use cases for this and what you think of it, and we will definitely raise it up to our developers as well, where they want to know more of feedback on the ground of how useful this functionality can be. We want to know, let's say, the use cases as well. So just to show a little bit of the video, where there's a use case for downtown Singapore, where one of the scenarios is no CAV. CAV is a connected autonomous vehicle. And then another part is where it's 100% CAV. So this is another scenario over here. And what's happening here is that on the left is the no CAV scenario, and then on the right, it is the CAV scenario. So this middle line, you can go left, go right, and then you can see that the speed, all this KPI output that you want to look into for different links, for different junctions, you can. And then you can toggle across the different scenarios. So this, we think, is a good conversation starter and also a good viewpoint to show, especially not just on the software, but also, let's say, you can project it out and give stakeholders a better view of what you're talking about. So do let us know, of course, yeah, if you are there's an interest, we would like to hear more as well. And of course, you can always zoom in further to the cars and then see what's happening on the ground as well. Okay, now we go into Viswalk, where of course there's a Viswalk specific, but also under the Vism framework, where we mentioned, let's say, the attribute modifications and some other parts where the model archive and some added like a usability function as well. So all this under Vism framework, but of course, since it is the same GUI, it is also considered under Viswalk. But what is Viswalk specific is then the beam import that's extended. What's extended is the beam import for the staircases, where there's more compared to even Vism 2020, there's more of the staircase different shapes import as well. And then the CAD import for 2019 version. And then also the formula routes using the routes attributes. Stair selection, which I'll talk about, and then the queues with defined spacing, and also the nearest neighbor attributes and the RSET maps, which is more for fire engineering use case. So to refresh your mind a little bit about the integration with FDS, this was first introduced in Vism 2020, where there is the FDS is a third-party software, which is a fire dynamic simulator, where we can import and then have the fire visualization, and then also the FPD and FIC computation as well. So this is a Rainier case, which is mostly based in Germany, and then how we can actually output the visualization using the FDS import as well. So going into basically where the start of the fire is, so you have this part where it's burning, and then what happens after. So this sort of visualization you can show where it can be displaying heat release or let's say soot, depending on your FDS file output as well. And when it's also giving the FED and FIC computation, of course the pedestrians will be fainting, but what you can then see is that how harmful the pedestrians are. So typically, those that are near the fire room, it will be more harmful for them, where the computation will be higher, let's say, so the concentration as shown over here will be higher. And then this is where you can see how much in danger they are and how close to incapacitation as well. So this gives you more of an indicator. And as mentioned, this was in BISWAP 2020. And moving on to what's been happening this year. So this is more for the safety engineers. So when the fire safety engineers perform an assessment of life safety in case of building fire, they usually compare the ASAT, which is the available safe egress time, to the RSAT, which is the required safe egress time. So minus this off, then they do have this safety margin over here. And while ASAT focuses on the fire, and RSAT then focuses on the occupants. So then the analysis of both ASAT and RSAT are conducted on the basis of maps. So if you subtract it, as mentioned, then you get a safety margin. And ASAT describes the performance of a built environment in terms of resistance against the consequences of particular fire. So then this is achieved by determining the time when the criteria of certain fire effects are exceeded. So this part is not calculated in BISWAP currently, because this is focusing on the fire part, but since BISWAP focuses on the occupant side, so then we are able to capture the RSAT, which is the occupant's egress out of the building. And so this is calculated in BISWAP. And just to show a little bit more of what, how it looks like, the RSAT map is then basically in the trajectory, then at every grid, the last point where there is occupants. And as you can see, those that are not, let's say, passed by the occupants, then it is under this NAN. Whereas those that are passed by, then it is under this color trajectory. And in this walk now, then we have this map color trajectory as well. So this gives you more of an idea of, let's say, where to put, let's say, the technical installations like the sprinklers, and then the sort of ventilation that you need in the building as well. So this is sort of what you can output in BISWAP, the map that you have, the RSAT map, and then the last occupant's time on the particular group as well. Okay, and we're moving on into a stair selection. This is the existing method that was previously before 2021. So what happens, especially when it's a long platform, is that because how it's computed in BISWAP is then from the area central, the center of the area. When the platform is so huge, the area center is here, and then even when pedestrians are exiting over here, they will use this route because from here to there, this is the shortest way. So they will not go from their particular pedestrian location. But after BISWAP 2021, this is now improved, where you can select for past choice method instead of area position, it is now pedestrian position. And then now it makes more sense, especially when it is a long area. instead of going from the area center calculation and computation, it goes from the pedestrian position trail. So you don't have to divide up. Like, I think if you're not quite familiar with like this platform simulation previously, sometimes we also suggest to divide up the platforms and then how it can be computed better to the destination area, where now you don't have to anymore. And going towards the more pandemic modeling, we have also set out the queues with the distance of pedestrians with each other. And what happens is that you can now set where you can have 0.4 meter spacing, so exact spacing, or in Singapore context, for example, we usually have a 2 meter spacing. So as you can see here, pedestrians then queue up properly. And usually, previously the standard default, what happens is that they have a smaller spacing in between, and then towards the back of the queue, then it becomes a bigger spacing. But then right now, you can have a definite spacing that you can compute. I think what they mentioned was you can compute even up to 5 meters of spacing they have tested, and it works as well. And again, a little bit as well of the pandemic modeling, where you can compute who are your nearest neighbor at any point during the simulation, and then the nearest neighbor, the distance, and of course under this list then you can get the nearest neighbor that's in numbers, size, or like other different attributes under nearest neighbor. And then who qualifies as a nearest neighbor, then it is under this computation of this experience level of service, so the experience density. So those within 2 meters, then you can have as a nearest neighbor. So those that are outside, then they are not qualified as. But then you can have the sort of the one that's the closest and nearest to you. So this as well, imagine with as well attribute modification, you know that there's a nearest neighbor quite close to you, and then what happens is you can then reduce your speed, for example, even during the simulation. So that is mostly the end of what I wanted to introduce about Visum and Viswalk. If there's any questions, do let us know or let TMS know, and then they will forward it to us. And looking forward to your feedback after testing out the new features. And what we want to highlight over here is that because of especially COVID as well, there's many more even webinars that's been happening. And do check it out, where there's a free online webinar program. Every week there's something, and then the webinar archives as usual, which is under Visum, Viswalk, and Bistro. And some of the ones that we wanted to highlight is the Bistro session 1 to 5, some COM programming in-depth talk, and then also for Visum traffic dynamic assignment series, and then for Visum as well, and then the Viswalk for the real world comparison that we wanted to highlight. So really thanks for having us, and as well your feedback always matters, and thank you for helping us make Visum great. So I will pass on to my colleague Gobi for the next session. Thank you.
Okay, thank you, Colin, for your presentation. 好，那我们接下来就是会请 Gobi， 他是Visum的建筑师，他会来介绍一下Visum跟Bistro 2020的协同。Gobi, can you hear me?
Yes, I can hear you.
Okay. May you start your presentation?
Okay, just a sec. Let me share the screen.
Okay.
Can you tell me, can you see my screen?
Yes. Yeah.
Okay, hi, good morning. This is Gobi from PTV Singapore. I'm working as a Director of Services for Asia Pacific region. I'm sorry I cannot share the video because there's a problem with my video. So for my talk is for this morning, okay, it's regarding Visum. What is the new features which is being implemented in Visum 2021? So let me take you through. So before I start to elaborate more in detail of the new features, let me take you through, like some of the, ongoing or, the ongoing development, which is from the past to the present. Okay, so from what you see, it's from 2016 to 2020. So in 2016, like we have improved the 3D display, simulation-based dynamic assignment, runtime optimized variant of 8-way-based assignment. So in 2017, we have improved the multi-modality interpol trips, vehicle sharing, ride polling. In 2018, route transfer to VZIM, headway offset optimization, dynamic matrix estimation. In 2019, we have introduced autonomous vehicle, e-mobility, support of ABM, support of Python 3. So, as what I'm explaining, it shows that, how committed PTV, to our customer. We constantly improving and introducing new features in our software. Either, to minimize the customer's work or to have a better features which can be modeled more in detail. So for the VZIM 2021, okay, which I'm going to talk for this session, PTV has introduced under public transport crowding and fail to board, and for under multimodality, it's ride sharing with the e-vehicles and holding areas and other scenario management for public transport. So the key features have been introduced for VZIM 2021 is crowding in PT, ride sharing with e-vehicles in intermodal assignment and auto demand calculator. So let's say, okay, for timetable-based capacity constraint assignment, okay, we all know crowding in public transport become more and more a problem. More people are using public transport, and to achieve at the same time to achieve the climate protection goal, even more people have to shift. The infrastructure can handle more supply. The available capacity is not limited. How do people react? VZIM, for some of you, who already been a VZIM user, VZIM only depict crowding in vehicles. Means the discomfort not to find a seat or be squeezed in a full train is reflected in a higher perceived travel time. But the new functionality depicts the circumstances where the trains are full of passengers fail to board, the capacity of vehicle can be exceeded, and the passenger have to search for alternative route at the station. So conclusion is new features under hard constraint. VZIM can reject if, let's say, if the capacity of the station is if the train capacity is 1,000. But at the station there are 1,100 passengers, so only 1,000 can board. Another 100, won't be able to board. So this will be, you can do very realistic the public transport model. So status, considering discomfort, previous version, the capacity divided by volume indicate the discomfort of vehicle journey item. The time using this journey are perceived longer. The impedance to use this journey is higher. Every passenger served, even the capacity exceeded. So this is in the previous VZIM version. With the VZIM 2021, fail to board. So VZIM will stop if, let's say, the passenger waiting to board is more than the current capacity of the vehicle. Okay, the vehicle have a maximum limit of occupancy. Passenger who wants to board a full vehicle fail to board. Passengers have to do search for an alternative connection, starting from their stop time, starting from their stop and time. If no alternative is found, the passenger gets stranded. So it basically VZIM will tell how many passengers who couldn't board, the train. So it gives an advantage of useful information for the planner. It's like capacity, analyzing capacity of the station itself. So quick one, how to capacity constraint assignment fail to board in VZIM, the procedures, timetable assignment, drive volume and vehicle journey items, journey items are sorted by starting time, the volume of the boarding and transferring passenger on the first overcrowded vehicle item will be reduced to the maximum capacity. All connections will be affected equally. The cutoff connection will start a search for alternative at the given stop and time plus 1 second. Extra search parameters rounding are applied to reduce the number of alternatives. The alternative connection will be connected to the cutoff planned connection. Those connections will be marked. So the output which you can the user can get, okay, the connection is marked with the number of breaks. So you can see that number and share of passenger failed to board per journey item. In addition, failed to board without alternative. Risk failed to board, which is calculate the risk delay at the end of connection, like 5 plus 15. So this is the formula. So what is the the delay? So number of passengers failed to board at the stop, and then a ski matrix of the risk delay of failed to board. So what you get here is on my on my right, the picture of, okay, so 80 people are entering the the corridor, the station. So the red color is how people are failed to board. So this is a capacity constraint assignment, failed to board. So then the next feature is dispatching a ride-sharing fleet with e-vehicles. We all know, the electric vehicles are one of the most talked about topic in our transportation planning and planning industry. So with Vizu now we have incorporated the e-vehicle mode. So what you can do with e-vehicle mode analysis. So what Vizu 2021 offer to the user, limited range, limited battery electric vehicle, defined ranges, conservative strategy, calculate longest distance for recharging station in network for buffer, and minimum charging threshold return to charging facilities. Recharging is priority. No trip requests are served. So these are the options which the user can define, to define the e-vehicle specification. So then there's another features under e-vehicles which the user can define. So define charging time. So for each charging time, how much time the e-vehicle will spend. Always complete charging cycle. So trip requests do not interrupt charging time. And charging area. So basically, the charging area is represented by a node. So we need to define whether the node is charging station or not. So maximum range. So charging duration to 80%. So means like 30 minutes. So charging duration of 80% to 10%. So additional 10 minutes. So all this information which you can define inside Vizu. So inside Vizu, so that when you run your e-vehicle analysis, all this information will take into consideration. So then the second as part of the e-vehicle is goal of holding area. So as we know, optimal routing, when there is an inactivity during the tour, vehicle will reroute to chosen central location to wait for the next request. But may accept a new call while relocating. Trip requests do have a priority. Ensure that vehicles at predefined location in the network. Previously, the vehicle randomly showed up at the first pickup location. So another features which have been added into Vizu 2021 is ride sharing with intermodal assignment. So previous, I think some of you with the Vizu experience, you know about PUT auxiliary. So PUT auxiliary means that the vehicle can use private network, private road network, or the public transport. So what PUT has done is for Vizu 2021, okay, that they have come up with a new assignment called intermodal assignment. So intermodal assignment means combination of demand response transport path links together with traditional public transport. For example, start with the train, changes then to a ride-sharing car. This assignment already exists in Visum. On the right side, you see a list of path links. You know, the demand response transport links in yellow color. Okay, the bus link in green, both as part of one path. So with the intermodal assignment, okay, the assignment look at, you know, the picture. It combine, you know, sharing mode with the public transport. So a trip which is start with the public transport, then later can be the interchange with the ride sharing to reach the destination. So the other way around. So other improvement we have done for the in Visum 2021 is, you know, for the assignment, we have. So we have, you know, like increased the, you know, the assignment speed faster up to factor 2, more stable and faster convergence for the intermodal assignment. So warm start. So under, you know, like intermodal assignment, these are the workflows. So here you see the workflow of intermodal assignment. The crucial point is that, you know, for the route search and the route choice, we need travel times of ride sharing legs. There's no formula which gives us this value. So we perform a tour planning simulation, derive the experience, travel time. To add some stability, we aggregate the experience detour factors of all realized trips inside a certain main zone relation. So this is the, you know, this, and perform a new route search or route choice using the updated travel times. So this go around for many iterations, take some time. At the end, we all have a converged detour factor, but if we restart the assignment, we cannot use them as initial value. So the point is, the first for the first, we need initial value until now, one global value. From now on, one can define individual vehicle for each main zone relation, like in this main zone matrix. Warm start if you use the final detour factor from the previous assignment, far faster convergence for, you know, like for faster and better convergence. So overall workflow is, you know, it's a combination of macroscopic and microscopic. So under macroscopic, you know, it involves route choice, then split routes, okay? So split routes between, for ride sharing, where as part of the ride sharing, you know, it involves generate trip request, tour planning, aggregate result, then it feedback into ride sharing, then send back. So as you know, some of your Visum model, you know, it cannot be run in one iteration. It has to be a loop. So until you get a better convergence. So this is what, you know, you get for your initial value. And the result of the analysis, then you can see how, you know, the ride sharing vehicle in public transport assignment. So it's with the desired line, you can show the distribution, some of the waiting time and the demand. So the blue is the waiting time and the green is the demand. So that's on the side. So let's say in case, you know, if you want to use ride sharing without tour planning. So what is tour planning? Tour planning is an add-on module to have a, you know, like activity-based activity demand based. So if you don't plan the DRT, the service, fleet, supply parameters, and then if you want to have a certain, you know, like a kind of overview study, assume with a certain performance, that you can use the route search, route choice, and, you know, like to come up with what is the quality DRT. So, sorry, you know, what here, that we're trying to show from PTV side, that if you have a detailed data, then you can have, with the tour planning. If you do have a, like limited data, input data, then, you don't need to go to detailed analysis. You just can have a overview analysis to understand where the demand is, where the ride-sharing demand is. So then the fourth features which has been added into Vision 2021 is auto demand calibration. So what is the auto demand calibration tool? So some of you are demand, so which is a trip gen, trip distribution, mode choice, and yeah. So when you have, as we all know, a demand model is more or less a machine which produces 3 matrices. For example, 1 matrices for each mode. So in here, walk, bike, public transport, car. And typically the model split which comes out of the model is not completely the same as it's observed in reality. If that's happened, how to solve it? So, on my right, I show the model. So, the split of what is the car, public transport, bike, and walk. But in the reality, okay, you can see the car portion are much bigger than what is model. So how we can fix, so from the data which you collected, the survey, to put into the model, to adjust the model to match with the survey data. So let's say in case if the model and reality have a different mode split, okay, analyze the reason for the difference. Okay. So first, of course, you just can't simply apply the calibration tool. First, the user need to understand. Okay, what is what went wrong, or okay, why the model result and the reality or the survey data is inconsistent. So analyze the reason for the difference. Person group segmentation inappropriate. Different behavior in different area, then extend the model accordingly. There's always remain a certain data that cannot be solved. So I think most of the demand models knows about this. Then manual calibration is extremely time consuming. If you require to do manually to go and check what to be adjusted, what to need to be increased, reduced. Most of us, as a visual model, we know we are working as a city-wide model. So it's like 500 zone by 500 zone. So if you go doing manually, it will time consuming, it will take months. So under demand calibration tool, okay, for this situation, okay, PTV have developed an add-in which automatically calibrate the demand model. Okay, so how it works? So with these functionalities that you can put what is the mode split, what is the procedure, okay, the calibration object, okay, is it based on a model split or average travel distance? So additional calibration level, person group, okay, then the metrics which we are going to use. So then once you click the the function, it will improve the result. So like to understand more of this function, I think with this session it requires more detail, more longer time to explain. If you have further interest, please contact us, then we can have more detailed discussion. So with the demand calibration tool, so now you can go further detail. So under this, for example, for person group people, you can go for student with car, student without car, employment with car, employment without car, non-employment with car, then non-employment without car, retired with car, and retired without car. So with the calibration tool, you have a survey data, you have a model data, then you can bring in, then you can adjust to match with survey data. And at the same time, it can go as detailed as it can go for the demand segment. So under and the next part, Okay, so there is a limit to certain relationship. So certain relation. Okay, so as you see, so where it's limited. Okay, within 4 steps. So sorry, under demand calibration tool, what you can do, you can use under for VZ and VZ 4-step, 4-step logic choice model. So then the fifth features which is added is new visualization. So PTV has enhanced activity profile and SBA vehicle. So SBA vehicle, you can simulate individual vehicles for dot simulation during the assignment. As we know, again, this is part of the demand calculation. So each demand calculation there's an activity profile. So this previously the activity profile is only can be viewed on a table format. So now that we can see in a more graphical format. So the activity profile follows a generic concept. Activity are displayed on time axis. Concurrent activities are stacked on top of each other. Activities can be classified by any attribute. Activities can be filtered by reference object. Limit the activities by filter formula. Addition, disaggregated views, and synchronization. So actually, you can see how the activities, when you calculate each step, how the activity further disaggregated. So again, I show the ride sharing. Okay. So during the ride sharing assignment, post assignment, that the user can view visualization of ride sharing tour legs. So tour legs. So under each legs, with the passenger of more than 4 passengers. So 3, 2, 1, and empty trip. So number of vehicles in service over time. Network-wide assessment, utilization of vehicle, and color-coded by occupancy. And for the activity visualization, so activity-based management, ABM, that we can visualize the ABM activities. So what is the percentage of people working, shopping, others, leisure, home, education, by tertiary, apprentice, secondary, primary. So previously, all the information you can only view in table. So for someone with a good Excel knowledge, they will take from visual matrix table and make a graph in Excel. So now you don't need to do that. You can do within Visual itself. So again, as part is for public transport, so example for line blocking, visualization of line block items, amount of buses to operate a timetable, classify by journey layover, specify to a charging depot, to define the number of charging stations needed, to visualize the charging power needed. So all these be visualized in a. So the last features, as part of the visualization, I'm not sure whether, in Taiwan, that, the user has explored simulation-based assignment. If you do have, so now, with the simulation-based assignment, previously, the assignment, you only can see on a volume base, on a label format, how many vehicles on this link and, on all the links. But now what PTV has done is take it to the next level, that, each the trip in the assignment can be visualized as a dot simulation. So what is the motivation for PTV to make SBS visualization? To better understand assignment result, to identify network coding issue, to support calibration effort to present SBA result. Let me show you a video. So what you see on my left is, and on my right is the SBA assignment on Visu. Okay, so on my left, like how the simulation is. So you can see here, okay, under here, like the dot, which is the green color dot, means the speed is either free flow or accepted speed. The one with the color is the vehicle where like there's a delay, vehicle gets stopped. So at this point, this exit ramp, it shows that there's a merging issue. So again, from our understanding with our Taiwan customer, so far no customer has used SBA. So we encourage the user to explore SBA, and from PTV side we are happy to assist. So that's all from my Visu presentation today. So John, can I straight go to Bistro? Hello, John.
Hi, Gobi.
Can I
finish your part?
Yes.
But we have about 5 minutes left. Can you stop in 5 minutes? About Bistro? Okay.
Okay. Yeah.
Okay, please.
Okay, so that's all for my presentation today for Visu 2021. Definitely, like with Visu, okay, to do demo and as part of this session, not enough time, and we hope from PTV side that the participant who's in this workshop, please contact our colleagues from TMS that we can have a more detailed discussion of each features which has been explained just now. Okay, that's all from my explanation for Visu 2021. In 5 minutes, we will see. I'll talk about Visu 2021. Okay, thanks.
Okay, thank you. So yeah, I'm going to present the Bistro part.
Yes.
Okay. Please.
Okay, just on the side. John, can you see my screen?
Yes. Please start. Thank you.
Okay. So again, thanks for having me again. So now I'm going to talk about PTV Bistro 2021. What is new in PTV Bistro? So PTV Bistro, as we all know, it's more for traffic impact assessment analysis. So let me quick take you to the features. So the highlight of PTV Bistro, for 2021, which is the merging models, model updating, traffic signal control list, stop bar and crosswalk setback, visualization of turning red eye, and PTV visit import improvement. Before I explain more in detail of each, added new features, let me take you, show you, okay, regarding PTV planning tool, which is accepted in FHWA. So as part of the US Federal Highway organization, they do have, for planning analysis, they do have a few categories. So the categories are sketch tool, travel demand, deterministic HCM tool, traffic optimization, macro simulation, meso simulation, and micro simulation. So under each planning analysis, they do use software PTB and non-PTB. But this table going to show you, okay, for each planning analysis for USA FHWA, okay, how PTB software fit into each planning analysis for this association. Sorry, for this organization. Under sketch tool, okay, we have Bistro. Under travel demand, we have Visum. Under deterministic HCM tool, we have Bistro. Traffic optimization, we have Bistro. Macro simulation, Visum. Macro simulation, Visum and Vising. Micro simulation, Vising. So it clearly shows, okay, that PTB planning tool, planning and engineering tool are used on all the planning analysis study. But compared to our competitor, some of them they are lacking. So this is a table not PTB produced. This is a table produced by the US Federal Transportation Organization. So with Bistro 21 now, okay. So with as part of this improvement, what PTB has done in the Bistro is we like to have more place system with more integration. So the way we look at it is, if for our customer, okay, we don't want the customer to whatever work which have been done in a different platform, like in Visum or Vising, cannot be used in Bistro. So the same thing, for if you have a network in Bistro, then you can use in Visum or Visum. So PTB concept is more focus on urban mobility system concept, complete system with more integration, highly applicable to large agency like government authority, road authority. Okay, bridge the gap between traffic operation and planning teams. PTB Bistro is a low law with agency. So let's say if you are working in an agency that you do have a Visum, but the Visum is is a for example city-wide model, like Taipei city-wide traffic model. But in case that if you want to just focus on a small area, that you can use Bistro. So the model which you have in Visum, you can cut the network and analyze in Bistro. And from Bistro, if you want to do further simulation, you can export to Visum. So how does the urban mobility system works to connect our products, which is PTB products? As we all know, okay. So that PTB Visum is not only a traffic modeling tool. It can it also function as a transportation data hub. Okay, it keeps all the data. So what are the data it keeps? Travel demand model, the OpenStreetMap, OSM, the OpenStreetMap data, GTFS, for public transport, big data providers. Okay, so big data providers. So once you do, with the central data, then Visum you can export to Vising, or you can cut a small area, run big. So with Bistro, how it complement with with the PTB urban mobility system works is the traffic count signal data in Bistro, that either it can be kept in Visum, or from Visum it can be exported to Bistro. So existing Synchro or Bistro network can be exported to Visum. Day-to-day workflow in Bistro can be in import-export from between Visum and Bistro. So here PTB Bistro role is provide engineering detail to the system. Maintains the system through the daily engineering efforts. So with features which has been added or put into Bistro 2021 is model merging example. let's say if you do have two models, okay, that like one model in Vistro, another model in Visum, you can bring these two models together in Vistro. So write Visum.NET file in Vistro, merge multiple models together, helps with use case of building master model in Vistro, combining multiple synchro model in Vistro. So again, from explanation, the picture tells more detail. So you have model 1, model 2, okay? But if you want to merge together, so now in Vistro, you do have a tool that you can merge together these two models into one. And model updating. So again, you have two models, you want to merge, okay, you want to export, or in another example, if you want to export the scenario 1, the data like signal, the geometry, turn volumes to scenario 1. So the features has been built for you. Okay, model updating base model and scenario data like signal timing, geometry, lane configuration or volume, useful for updating peak period, time of day information, updating a base model data from a test scenario, enables you to convert an external numerous 2 of a day models files into one managed PT Vistro model utilizing scenario management. So includes traffic signal control summary to list, edit traffic signal control ID numbers, manage your traffic signal controllers with editable description field, provide detail about the signal control like manufacturer, type, and last inspection of a day. So all this that you can from Visum to the Vistro or from Vistro to Visum. So in Visum, okay, in Vistro, part of the new features, stop bar and crosswalk setback. So these features more of a detailed geometric coding. Okay, the location of cross and stop bar can be modified with the positive and negative setback. So what is the positive and the negative? So whether we can define whether the car or the pedestrian sits the weight before the stop bar or they stop slightly beyond the crosswalk. So this is this is a stop. Vehicles they stop before the stop line. Some they overshoot. So enables you to size intersection size with the visualization, optimization, setback will transfer to Visum for accurate simulation. All the detailed geometry that user put into Vistro can be exported to Visum for simulation.
Excuse me, Kobe.
Yes?
You have 3 minutes left. Would you finish in 3 minutes? Thank you.
Yeah. So for model updating, then you can have a like a detailed turning radii input are now visualized in PT Vistro 2021 to show realistic condition at intersection. These radii input are also utilized in HCM 6th edition multi-model calculation. Radii dimension entered in PTV Vistro will transfer to Visum for accurate micro simulation and sizing of intersection width for visualization and better optimization. So detailed geometry will be included in the delay calculation. So then the next features which is added is PTV Visum import improvement. So you have a Vistro model if you want to simulate individual vehicles, you can export to Visum. So you don't need to do the network again in Visum. So in click of button, the Vistro network will be in Visum and you can run your simulation. Enhance or PT Visum 2021 ANM import or utilize updated position item like stop bar, crosswalk, radii, medians to exact coordinate and location in Visum and correctly size the intersection and node structure. Enable you to create a powerful 3D out of the box simulation with a click of button directly out of your PT Vistro 2021 model, resulting in a huge time saving. So you can see the connection. You have a Vistro network, click a button, everything will transfer to Visum, then you can simulate the Visum simulation. So then the last one is Visum import improvement. So in Bistro, if you have a detailed interchange model, you can export to Vising. So as you can see, the top image is in Bistro, the bottom one. So that's all for my Bistro 2021 update. Again, if you do have questions, please contact. Either you can ask now, or you can contact our colleague from TMS. Then we can update you more in detail. That's all from my side. Thanks for giving opportunity to present Bistro, Visum, and Vising by my colleague, Vising Bistro by my colleague, Hao Min. Okay, thanks again.
Okay, thank you, Gobi. Thank you, Gobi. 好，那这一节就是目前的事，然后请大家可以到外面去用餐，还有备有餐厅的部分，然后请大家在11点10分的时候到大家这里，谢谢。Hello, Gobi and Hao-Min. Thank you for the presentation.
Okay, thank you.
Thanks for having us.
Thanks, John. Yeah, thanks for having us. Okay, bye.
Thank you. Bye bye. 好，把它弄到桌面上。看这个片面的，好，手枪。你是这个。没有声音。有资料吗？你说这个的资料吗？哦，有，是吗？你刚没拿到对不对？哎。谢谢。他可以去公益厅的是 YouTube 的话，可能是刚我那个视窗没切到，要查一下。对。这是你的，不是。哦，这个是稍等一下。不要试一下。那可能会改。好，等一下，有点忙，稍等一下，因为晶晶好像去那个。谢谢。你都有影片吗？
没有，因为我怕吵死。
OK。
对。是啊，谢谢。你就准备上。应该是对，就需要的话可以试试看。我给你签到一下。
我刚在柜台签的。
哦，签的是不是？我还没给你那个10分钟。可是如果他要会当
是不是我视窗？
我发现因为经济好像有加进来。我们
我帮你看到那个，
他们加薪，看一下。哎，等一下。
现在画面是俊佳。
好，等一下，我看一下。哎，晶晶还没回来。应该来得及，再等太长，太长。
对呀，他排我，被带大的，只要可以
讲给他听。其实也可以，
可是模拟那个就
哦，不要说，
也不是讲
都来，有一个就为什么那么多人？他之前就说请台中的名字嘛，然后我想说就是找你对，应该也没有别人，他就是台中公司，也不是只有2个人，他只没弄名字讲而已。
不太确定。我记得有就是
你下一次啥？下一次
我有回去过吗？还有一个好像那个是哪儿？前面说是对啊。下一个。可是我觉得 哦，应该就挡住了。哦，对对对，
我拍一下。
对啊。每个步秒2动，然后位移就比较对。
可是实际你转到别的开放，
对。
光上去。
它可以直接加入，可以一起加入。
我这边看有一个小花是放。
你现在有没有先定我有分享吗？这个是日本的，可是我看你之前到的，就是下周如果你看到如果你这个部分可以的话，那要可是我参加线上有。然后你下面刚说后面的那个这个现在是我现在这个是用来视窗的。这是视窗的。对，所以那接下来几个就一样的，用这个方式。所以我用我直接去到那个。然后你帮我切到你的那个画面一下。你说哪个画面？就是Google Meet那个画面，帮我切一下，我看一下。好，这样吧。你看一下。目前是黑色的。是我要分享画面。他就是现在正在分享漫画，我叫应急分享。看一下。 很少多这个的话，这边有那么好吃，这边上面还是黑的，我已经申请了。这边他们是1.3万的，就是那个金融给的，所以那个对啊，可是为什么还是跳可是你在选择的话，可是我们喜欢做工作的事，对啊，而且我已经很想的话，为什么就是不行？我在确定的时候，我很想上。我现在有点想。明白。我们还在里面吗？我现在我是生产，就是中间的生产，对，3个视窗，然后我按这里那个说的3个视窗之后，就是它是机会。现在是你的画面，我这个不行。现在的画面为什么是你的画面？还是我把它关掉。视讯关掉。这样。现在是一个镜。那就是有镜，没有后面这个。是我最开始。接下来进行下一个尝试的演讲。接下来我们是科技的经理 看一下，他来介绍一下自驾资源，然后这个介绍。那刚刚有关于过就是自驾车的投资跟台湾的事情呢，我也是目前跟科技有合作对象，那有邀请转换先生上来，谢谢。
好，各位午安。就是大家知道，就是今年度就是受 COVID-19 的疫情影响，就是针对这家公司多少都受到一些影响。然后对我们公司来说，最大的影响应该是说，从疫情以来，就是我们会一直接到国外商打到给我们的饮料在产品。可能就是因为他们没办法到直接到限定就到台湾来，所以让产品就需要在台湾的话，然后目标还是应该算是这一季新找到了一个合作。然后如果大家有听过目标 AI 就是一个 AI 影像辨识来做限定价值系统的一个产品。如果大家没有听过的话，可以先看一下这个影片，大家一起来理解。
Research shows that a forward collision avoidance system might have prevented or lessened the severity of injuries in 79% of rear-end crashes. Mobilized collision avoidance system gives you time to react. Mobilized will constantly scan for the road ahead. The AI-powered IQ4 chip processes, analyzes, and identifies pedestrians, cyclists, vehicles, lanes, and signs to detect potential dangers and warn drivers with real-time alerts day and night. Pedestrian and cyclist collision warning. Lane departure warning. Headway monitoring and warning. Forward collision warning. Gives concrete insights into driver performance so you can give your drivers the support they need. More than 50 million vehicles worldwide are equipped with mobile driver assist technology. No need to purchase new vehicles. Mobile AI Connect.
看到，基本上 OBO 他们大概是1996年两位那个以色列的飞虎他们所成立的一家新公司，然后多年以来都慢慢的受到车厂的采纳，然后就是在那个车子上面装上 AR 天猫飞车，然后一直到2021年他们被 Intel 给并购进去，然后目标就是2021年要跟 BMW 出他们的一台自驾车。然后目前这个可以见到大概有1000万，全台湾全球大概5万的车厂已经安装了所以基本上如果有很多的数量的车，去安装的话，它至少可以比原本就是那个目标是。对。就是它原先的现在其实就是用透过 AI 辨识侦测就是会动作，像车子啊、行人等等，并且提供一些资讯，然后帮他们得到就是更安全的驾驶辅助。 但是因为它现在已经有5000多辆的5000多万辆的车已经安装了这样的一个系统，所以它可以进一步在他们运行的时候去收集就是路像是一些电线杆啊，甚至一些交通标志，甚至一些标志标线的一些资讯。然后甚至还可以针对像是路面运动都可以进行及时的资讯收集，并且回报给比如说主管单位、让主管单位去做一些就是路面喷动的一些处理。所以他们在台湾的预选大概是smart travel，就是smart travel的部分是保障驾驶的一个行车安全，然后 smart sensor 他们等于是透过群众外包的方式去收集路面然后道路的一些相关的资料，然后最终这些资料要回馈到 smart city， 就是让一些主管机关就是县市政府做智慧城市，他们有一些资料出去让他们做更好的决策。然后这是他们 service 的一个影片。及时的去收集这些道路跟相关道路产的资料，然后因为它是用群众外包的方式，就是它分析的速度会比我们一般，就是比如GIS厂商到县去每次都要做它的社会啊，做一些规划等等，它跟进频率还要更快。那基本上就是用两种群众外包模式，所以他们会透过车辆上安装了 UI 及时收集道路上的资讯，然后接着他会做一些基本的过滤以及重要资料的一些处理，上传云端。基本上会把就是原始的影像资料上传，因为他们受到欧盟 GDPR 的一些规范，所以他们对个资这方面检测很重的，所以他们基本上资料在第几端就会处理完。然后把处理完的资料再上传到云端去，然后最后生成这种它刚才显示的一层一层的 GIS layer， 然后就可以透过这个 GIS layer 去做一些 smart city 的一些应用。然后基本上它否刚才大概就是一个比例。就是它否刚赛大有几个重要的第一个就是它对于他们的投入就是道路可以去做及时的一个设备，就包含像是一些绿灯啊，或是道路的标线，然后甚至它可以针对就是交通提供一些产像是水沟盖或是一些 道路附近的一些像是电线杆或是一些路等等，他们也做计时的设备。然后还有就是他们针对道路的铺面，因为我们知道就是其实现在很多县政府他们都是要外包一些contractor去做巡路这种，然后这些contractor发现，比如说道路的铺面有一些毁损的话，他们就会回报给县政府再派其他厂商去做修复。但是通过这种群众外包的方式，其实他可以更快的去知道道路哪边其实是有一些坑洞，然后做及时的回报。然后当然就是未来车子就是如果每台车都有装他们 mobile device 的话，它可以去更快的去找到一些 dynamic 就是动态的一些资讯，然后做更及时的一些交通资讯的应用。就像刚才提的，它的道路的资产的调查的资讯，大家可以跟我一下，像是车道线啊、一些道路护栏，以及标示，像是连车道的宽度啊、停止线、斑马线等等，他们都可以做 camera 的一个 AI 影像辨识。那另外道路外的话，像是一些标志、道路号志以及电塔灯杆，还有一些人孔盖，他们也可以做资料的收集。那这个就是他们收集的一个影片。就基本上他们都是透过 AI 的人工智慧的影像辨识去做这样的一个资料及时的收集。它基本上是完全一个自动化的过程，就是它在 Edge 端处理完之后，就上传到他们的云端去做更新。然后另外一块应用就是针对铺面，他们其实可以就是透过 AI 影像面去侦测像是坑洞、裂缝以及一些道路的颠簸的程度等等，然后以及有一些标志标线的完整度，他们也都可以透过这个方式去做一个巡检的任务。这就是他们秀他们如何侦测一些道路，就是一些坑洞的部分，就是你可以看到一些蓝色，就是他们透过 AI 影像辨识去辨识出哪边其实是有道路的一些坑洞。然后之后，如果就是在台湾他们的车辆更多的话，其实可以做一些即时路况的一些应用，比如说可以去侦测，比如说我们的道路速率啊，甚至一些就是我们说 incident 就是一些交通的事件等等，甚至有一些施工区及交通障碍，他们也可以做 AI 影像辨识的侦测。这是他们在巴塞隆纳建的一个平台，就是把他们的收集到的资料，然后提供给他们巴塞隆纳的一些交通的事业单位，做成一个 GIS 的图台，然后让他们去做一些参考。那可以看到上面的一些就是道路的速率的一些资讯，以及拥挤程度的资讯，都可以透过他们的AI 影像辨识技术去得到，以及一些交通的事件，以及他们侦测到哪边有行人、哪边有车辆等等。然后这张图大概是秀说，如果他们是如何透过 AI 影像辨识去做到定位的。其实他们就是透过 AI 影像辨识的影像去做一些就是自动化的推算，然后自动化推算在他们的地理资讯系统的图台上去进行一些就是标记的动作。然后他们平均误差大概会小于2公尺，如果未来有高精地图可以做辅助的话，误差是大概是在30公分左右。接下来说明一些国际的应用案例就是在那个英国其实他们已经收集了大概940个警告的标识，然后以及800多个路面的标线，以及6.4K 的坑洞，以及677个交通的号志。然后另外他们也会透过这种交通道路铺面的一些状况去做一些进一步的分析，比如说他们会分析坑洞跟刹车，就是刹车的一些关联性。然后大家可以看到这边很多坑洞的道路上，其实它刹车其实会比较多，也会影响它的道路的速率。然后另外他们也可以去协助，就是因为大家看到这张地图上，其实这些白色的虚线其实是他们的自行车专用道，然后这些就是热区图其实是显示说哪边是自行车流量比较高的地方，所以这套列出来就发现这个区域其实是自行车非常密集在行驶的区域，但是它却没有自行车的专用道，这可以提供就是县政府在未来规划自行车专用道上面做一个资讯的参考。然后另外它也可以侦测这些施工区的行为，并且拿来跟道路的速率做一些比较，做一些相关的研究。这是在纽约的一个 case。然后另外因为他们 Mobileye 本来是做主动安全的嘛，所以他们主动安全每次就是如果快要发生车祸的情形，他们就会做一个警示， 然后其实这个警示对于做交通来说，其实是非常好的一个 data， 因为这个就是我们所称的就是 near accident， 就是快要发生车祸的一个状况。所以把这些 log 做起来的话，他们其实可以去判断说道路哪边其实是比较常发生这种 near accident 状况，然后是不是就可以提供一些交通工程的单位去评估说哪边其实透过一些交通工程的改善，可以去避免这些 near accident 的发生，啊，进而确保就是用路人的一些安全。那另外他们也是针对自行车也可以有这样就是 near accident 的一些相关应用，这个是在那个韩国大邱的一个案例。然后当然就是针对行人的部分，他们也可以做一些侦测，也是就是透过 near accident 去侦测说哪边的行人的碰撞警告率是比较高的，然后就可以进一步做一些 smart city 的就是一些改善，比如说侦测人行道等等的一些工程。好，以上是我这边的简介，谢谢。
好，我们谢谢王凯平先生的介绍。接下来下一位我们邀请到就是逢甲大学毕业生许曼瑜小姐，她要来讲的是 B-SIM 学生研究成果分享，就是关于她的论文的部分，考量多元交通车流参数之半速动耗制、控制逻辑建构应用。那她目前是任职于道景工程有限公司的交通规划师，也担任过就是安方船务代理有限公司的业务部实习生。那我们现在欢迎她，谢谢。
它是不是没电了？我觉得是没电，因为那个是红色的。
你会有剩下那种，剩下中段，先帮我分享给我一下，好。然后那个然后第二这个题目透，
我们要分享。
啊，总算有。
走过来看到电脑之后，就不会这样。如果你是碰什么？这个声音好像在前面。
它是不是只是灯泡坏这样子？对，我在想，因为你分享第二荧幕，我这边是，所以那边只是那边不能秀出来。哦，是那边。
可是你这边踩到什么？这个打不开。
哦，对对。
现在是关的。这个要重下。然后我跟他的朋友进来。
不好意思，那个就是因为投影幕有点问题，就是大家请大家稍等一下。
应该没有找到什么。因为我发现我如果离开这个方的话，那个有声音就会变。太有没有可以缩小？先定一下，这个是可以。对，这个。那个遥控器刚好在这边，
可以直接压那个。
电脑这台吗？对，啊，可以拆吗？这个就是这个应该是摆那里吧？就是你觉得再起来那个线，线就好了。啊，线有。这时候忘了，完全是另外有这种，所以这里是硬体状况，所以电脑可能。音讯嘛，音讯是吗？谢谢。没有其他先接线。他会帮我方面动一下，让我确认一下效果。所以，就是刚刚我们先打掉它的讯号是帮它直播进去。
好，等一下，我先看看。你是说动哪里？
就是简报的画面。
哦，好。对，右下角那个简报。
目前收到的画面是这样。那个上面的是用第二屏。我目前是这个，我目前是这个。好。
不好意思，我们简报说好，那我们再请徐范小姐来讲我们这个主题，谢谢。
好，各位贵宾好，那我是今年从同感大学运输与物流学系的硕士班毕业的学生。那我今天要分享的主题是考量多元交通车流参数的半说明建构应用。总共分为6个部分跟大家介绍，包括了虚拟路口验证分析跟利用实际的车流数据去做模拟的分析，最后是结论部分。那一开始绪论，就是在讲说为什么我想要做这类的研究，因为在台湾多数的地区，的市郊区衔接处或者是干支道衔接路口都会有流量差异悬殊的特性。那如果在这些路口设有交通号志的话，会造成干道浪费不必要的停等时间啊，或者是有些车辆会做违规闯红灯的行为。设有闪光号志的话，干支道车辆就容易有冲突，行车安全上会有疑虑。所以这类路口呢，就容易发生事故，导致它的效率跟舒畅度降低。所以我将利用车辆侦测器去取得多元的车流参数，像是停等数啊、停等时间或者是占有率， 然后利用控制逻辑去获得一个符合现况车流的控制模式，再传回路段去执行，建构一个可以解决干道流量差异大，然后制造流量不稳定的路口控制模式。接下来是文献回顾的部分，总共有4大部分，我就跟大家快速的分享一下。耗资控制策略，我最后是选择使用半错耗资控制策略来解决这一类路口的问题。那这边有说到，它适合使用的是干知道流量差异大的路口。接下来就是触控耗资的相关文献，那我总共把它分为3类。第一大类是分析与评估，像苏昭明苏老师2004年的研究，他就是将半触控耗资使用在封闭型的社区路口上。那他去探讨说，它是不是可以增加路口的安全性，跟增加它的效率。那最后的结果是可以大幅提升的这样。第二类则是触控耗资的路网协控，因为触控耗资它其实没有固定的周期，所以在路段的续进的表现其实是不佳的。那就有相关的国外学者去研究这一类的问题。第3类则是优化实质参数的部分，就是利用一些演算法动态的去调整它的一些参数，像是最大绿灯时间、最小绿灯时间，去提升它触控耗资的绩效这样子。接着是成本效益分析法的部分，因为我后面会提出3个方案，所以我将利用成本效益分析法来评估我3个方案的优劣这样子。那顾名思义就是将效益跟成本转换为货币价值去做评估。像后面是相关的文献，这边有说到它最后分析出来的结果会与主管部门的最终决定相符，然后也可以使投资的设计更具有成本效益这样。那总结以上呢，半触控耗控是适合使用在不饱和流率并且干道流量差异大的路口，但是在传统的触控条件下是以侦测车辆为多，所以无法快速适应车流变化。怎么说呢？像是如果知道车流量小的时候，会造成地量的车需等候较长的时间才能达成触控条件。那如果车流量大的时候，触控条件又太容易达成，造成干道的绿灯时间减少。第2点则是成本效益分析法可以有效评估运输方案的投资效益。所以呢，本研究的目标就是建构以知道累积停等时间，就是它里面有包括时间跟空间的特性，然后了解干道占有率，去得到干道车流现况作为知道触动条件的半触控耗控。绩效评估方面就会用各方向跟整体路网绩效来做评估，最后以成本效益分析法来评估3个方案的优劣这样子。接下来是逻辑建构的部分，总共分为2部分。那我们刚刚上面说到，我会使用侦测干道占有率跟侦测知道累计停等时间这2个是我跟别的研究比较不一样的地方。是侦测干道占有率，就是了解干道状况时，知道触控条件可以配合干道车流去做出应对的策略。那第2个知道累计停等时间，顾名思义就是知道当下的所有停等车辆的停等时间加总。那就是结合了停等时间跟停等空间的特性，它不会造成停等过久或者是停等长度过长等问题，去造成误流这样。再来是红黄灯时间，它就是参考台中市的实质去做设定，然后看到最小绿灯呢，则是以10号之下交通尖峰时之下执行绿灯时间作为起值。然后知道最小绿灯是考量车辆跟行人都可以安全通过的需求来做设置。知道最大绿灯时间呢，我是将它以知道最小绿灯的时间乘上1.5倍当做这个值。然后最后是单位延长时间部分，单位延长时间就是如果知道的侦测器不断的被车辆触发的话，然后并且没有达到知道最大绿灯时间，它就会去做延长的动作。那我将这个单位呢是设定为1秒。再来是知道触控条件的部分，刚刚说有包含2个部分，第一个是干道占有率。那我们在公路容量手册可以看到说，高速公路占有率达7.5%的时候，车流状况是稳定；超过20%的时候是从稳定进入到不稳定的状况。那我的模式是使用在平面道路上，所以它的车种是比较多样的，然后受耗资干扰，所以我订定的相关的规则就是10%、20%、25%这样去做规则这样。接下来是知道累计停等时间的部分， 因为知道的车流量多寡会影响到知道开启绿灯的频繁度，所以当知道车流量越多的时候，我的起始门槛值就会设得越高。像这边的规则一样，0到100就是从10开始起跳这样子递增。那以车流量150秒每小时的例子为例呢，那它就是从20秒开始起跳，然后20、30、40、50这样做递增，然后去得到它的占有率之后呢，它再去对应到累计停等时间门槛值。当知道车的累计停等时间门槛值达30秒的时候，知道绿灯就会开启这样子。那这是它相关的架构。一开始就是干道长率，然后去感应知道是不是有车辆到达。如果是的话，干道就会去判断说它是不是已经达到干道的最短绿灯时间。那如果还是的话，它就会去了解说现在的干道占有率是多少，然后并得出对应的错误条件，就是我们的知道累计停等时间。那如果它有达到那个门槛值的话，它就会去做清道时间，然后执行知道绿灯。那执行知道绿灯，我们刚刚有讲到是有单位延长的这个部分。那这边所以它就在执行知道绿灯时间的期间，它还是会去循环说，是不是知道还有车辆到达？如果是的话，它就会去判断说是不是到达最大绿灯时间。然后如果是到达最大绿灯时间的话，它就会执行清道，然后换干道绿灯。如果不是，它就会延长1秒，然后再做一次循环，直到最大绿灯时间为止，这样子。那我是使用 VC 眼镜的子程式 VSPA 去做相关的建构。上半部就是干道的部分，下半部就是知道的部分。这是示意图。然后接着呢，就是去入口验证分析，就了解我的模式在干道流量差异大的入口的适用性跟有效性。那我提出了3个方案，跟定时号制跟先前研究的半中号控的模式来做比较。我的方案1呢是考虑干道占有率跟设置了最大停等时间30秒。方案2则是考虑知道累计停等时间作为触动条件的方案。方案3则是考虑两者。那去入口的假设呢，就是 T 字形入口，然后周期都是120秒。模拟情境总共有15种，都是根据半错误号制的特性跟参考先前研究范围所定的情境来做模拟情境。那这里大家应该都看得出来，都是干知道流量差异大的入口。那最后结果出来之后呢，我们可以发现，我的3个方案与定时号制相比，它的改善幅度其实都蛮高的，都在20%以上。那与先前研究相比呢，除了在饱和流率0.4以下，其实其他的部分也都有所改善。我们也发现说，在这张表相同干道比情境下的这张表呢，我们也发现说，如果干道占有率趋于稳定，只知道车辆变少的时候，颜值会下降。以及在这张表呢，我们也可以发现到，随着知道车辆增加呢，会导致知道开启绿灯频繁，去缩短了干道绿灯时间，使干道颜值增加。所以这就是为什么它3个就会往上一撇，然后3个点就会往上一点这样子。那综合下来呢，我们就可以得知，我3个方案的适用范围是饱和流率比0.4到0.8，然后干知道流量比最低建议值是8:1这样子。最后利用实例应用与分析的部分，就是我去调查现况的车流，然后将现况车流呢导进去模拟里面。那总共分为3个部分。那我是调查了台中市太平区东平777巷跟东平741巷2个相邻的 T 字形路口。那这是空照图的部分。2个路口呢都是普通20巷，然后在尖峰时刻的时段的周期呢都是120秒。然后这是2个路口的所有特性，有饱和流率比跟干知道流量比。我们可以发现它其实干知道的差异都蛮大的。有到28.1、30.1比1，其实都蛮大的。除了在东平路777巷分封这里，其实差异没有说那么大，干知道的差异没有说那么大，并且也没有在3个方案的适用范围里面。所以呢，我预测它的改善幅度会比其余3个时段还要来得小，这样。 然后最后的基本假设就是刚刚所说的上述的规则去做定定。然后模拟软体的交互的部分，我是使用 NAP 法作为预测模式的准确度的评估指标。那分别评估了成峰入网，都是以各方向总车辆数来做验证。成峰入网都有达到合理以上，然后分峰入网也都有达到合理以上，代表我的模拟值跟实际的值它差异是小的。那相关的假设呢，验证入口就是刚刚所说的平日的成峰入网。然后模拟时间是3700秒，绩效值从模拟后100秒开始，确保说我可以得到更像现况的模拟绩效值。然后绩效指标是以各方向跟整体入网的绩效来做评估。那每一个值呢，都是以改变乱数种子的方式做10次的模拟的绩效平均值。那结果出来，我们可以发现，在各方向平整研制呢。其实3个方案跟定时耗资相比，其实改善幅度都蛮大的，但有一些负值，例如东平路741巷这里，干道的方向它其实改善幅度都非常大，但是支道的方向却是下降的。那这是一个正常的现象，因为一个路口如果干道的效率变佳，其实就是用支道的效率去换取而来的，它是平衡的，所以这是正常的。然后再来是上半部777项的部分，因为它定时耗资其实表现就已经相当良好了，所以我们的3个方案没有办法做太大的有很大的改善空间去做改善。那它反而去平分到其他比较不好的地方，让它的改善幅度增加这样。那各方向的车队研制呢，跟刚刚所说的情形是差不多，我就不再多赘述了。最后是整体入网绩效部分，它有平均总研制跟平均定的研制这2个评估指标。那3个方案都比与定时它的后置相比，它的改善幅度其实都蛮大的，从24.8到18.4都有，所以算有大幅的提升。那总结方案1是干道绩效跟整体入网绩效改善幅度第一高，方案2是指导绩效这样子。接着我就利用成本效益分析法来评估我3个方案的优劣。那总共有3个参数在效益的部分，一个是空气污染，然后第二个是燃油消耗，第3个是时间耗费来做货币价值的转换。成本的部分则是设备的成本，去反弹设备厂商得知一些相关的价格。最后利用核心 CPI 年增率0.05%去做计算的话，最后的结果是以方案2为最佳的选择。最后是结论与建议。那我们可以知道，本研究使用多元车流参数设立新的控制逻辑，像是干道占有率啊，或是累计停等时间跟单位延长时间。然后在虚拟入网分析的时候，我们也可以发现，我的3个方案都比定时耗资跟先行研究的模式来得好。然后3个方案呢，是以方案1的干道绩效改善幅度最高，方案3的支道绩效改善幅度最高。然后3个方案也会因饱和流率的下降，造成干道占有率变化趋于稳定，然后导致错误条件无法发挥效用。并且绩效也会随着干道比例差异及饱和流率不同而改变，像是如果干道比的差异是大的时候，它的研制时间会比较好，等等的。然后也得出了我们的适用范围是饱和流率0.4到0.8，干道流量比最低建议值是8:1这样。在实际入网的模拟验证上呢，也发现说都优于定时耗资，然后在入网平均验制改善幅度从24.8到40.1，平均停等研制也从28.1到48.4，都是大幅的提升。成本效益就是用来评估我3个方案的优劣，然后最后算出来是方案2可以带来更大的整体经济效益这样。那建议的部分就供大家参考。那我们分享到这边，谢谢。
好，谢谢许曼瑜小姐的分享。那接下来我们欢迎就是淡江大学的毕业生张晨，也是来分享他那个硕士论文的部分。他是应用 V-Sim 的车流模拟，然后也是有用到 VEP 的 V-Sim 的 VEP 的后置控制策略的撰写。他的研究是包括B 型路权下轻轨后置控制策略的比较研究。 那我欢迎张晨先生。
各位先进专家学者、老师、各位同学，大家好。然后我是报告生，然后今年是刚从淡江大学运输管理学系毕业的学生。然后主要是我的论文的分享。然后我的题目是 B 型路权下轻轨耗资控策略之比较研究分析。然后以下是我的简报大纲，主要分为4个部分。第一个绪论就是讲说大概我的整个背景，我的假设的背景是什么。然后还有第2部分是模拟平台与资料收集部分。然后我们主要是以高雄 C7 软体园区站，然后作为一个研究的一个标的。最后会在实际去现况去做收集资料后，然后借由 Vising 这模拟软体去做模拟结果的分析。最后是我的使用的心得一些分享。第一个绪论分为3部分，第一个动机部分，因实地去现场去看后，发现说高雄轻轨第1期路网里面，轻轨沿线因轻轨通过路口之后，路面平段的时候，一定会对平面的那个车流量带来一定的延滞。第2个回顾了很多相关轻轨文献，发现大多数学的都是以等车道作为模拟平台，所以本研究选取是非等车道的模拟案例较少。然后研究目的的话分为3个部分，第一个是以非等车道的路口作为模拟平台，就是干支道关系，然后分为2个方案，一个 A 方案就是现况方案 ，B 方案是说想要借由说现况是属于3车道汇入4车道，4车道汇入4车道汇入3车道，然后东西向的支道部分属于2车道。那我们想要看说，如果干支道这样子的比例，如果在相差更悬殊的话，就是说支道比例如果是单车道来看的话，它的策略是否会有所不同？然后我们会使用系统模拟Vising 作为一个系统模拟的工具，然后去模拟高雄 C7 软体园区站，然后在满足现况之最小绿灯安全前提之下，然后引用这4种策略，然后最后会提出说，在不同的轻轨的班距和平面交通流量之下，适合什么策略。然后以下是我研究范围，主要是以汽车、公车、大客车和轻轨为主。然后本研究以非等车道路口作为模拟平台，是一个干支道的关系。然后本研究不适合轻轨车站，所以轻轨是随机经过路口的。然后以下是模拟平台与资料收集部分，分为以下3部分。第一个是 C7 软体园区站的现况收集部分，总周期是120秒，然后分为直走左转第1实项，然后第2实项是左转的部分，第3实项是东西实项。然后以下是实际的 Vising 的模拟的耗资设置的那个示意图。然后接下来是基本的一些参数的假设，列车的结束，那个车辆结束啊，然后平均在轻轨的车站的停等时间。然后本研究是从机轴72开始，到机轴73的这段时间开始去预测说，轻轨通过路口时候在平面实项之延滞状况。然后以下这个是实际测路口的一个数据。然后在测路口后，总共有这4个论点。第一个论点，轻轨是随着进入某一实项的，所以一定会切断另外一个实项，带来另外实项的延滞。第2个，本研究会以原有轻轨的实项为基础，然后并套用3种策略，然后去模拟说，这3种策略跟现况的这策略相比，换哪个策略比较好？对整体的绩效评估，车辆延滞是最低的。然后本研究是从机轴72开始去预测说对平面实项之延滞状况。第4个部分，本研究发现说，高雄轻轨主要影响的是成功2路的主干道为主。然后以下是引用了这4个策略，绝对、完全、部分跟全触动的策略。从上面这个策略来看说，从绝对到全触，可以看出说给予轻轨优先权程度从高到低，这也代表说对平面车辆延滞从最大到最小。但这是在等车道路口之下的一个模拟出来的结果。然后大多数回顾的文献发现，大部分的最佳化是以部分优先策略为最佳策略。然后接下来是 Vising 模拟的各种策略的架构图。然后这个是 Vising 的架构图，主要分为2部分，一个是 VAP 档和 PUA 档。然后 VAP 档和 PUA 档整个整理出来后，汇到 Vising 里面，然后和原本 Vising 的模拟平台去做衔接。 接下来是 VAP 档的一些函数的名词整理，主要有以下的部分。第一个是最小绿灯，然后最大绿灯，还有轻轨需求，还有平面车流的需求，还有剩余绿灯时间，还有时相的转换，一些相关基本参数函数这样。然后接下来是 VAP 档撰写，主要有这4个策略。第一个是绝对优先策略，然后完全的、部分的，还有全出动策略，还有接下来的 PUA 档。以下是我针对 A 方案，就是现况方案，4车道汇入3车道，就是南北方向4车道汇入3车道，跟4车道汇入3车道，对。然后东西方向是各2车道，然后以下这个模拟图是完全、部分和绝对的这3个策略的模拟示意图。然后接下来是触动式号志的模拟示意图。然后接下来是 B 方案部分跟 A 方案就差在说，知道部分是以2车道变成1车道，对。然后接下来是可调整的模拟参数，有列车的长宽度、最大加减速度、期望加减速度，还有使用的运距。主要是以平面车流是以每小时50公里，而轻轨是每小时40公里。然后以上我们模拟出来的结果会以2种绩效指标去做衡量。第一个是以vehicle delay 平均总延滞时间和 queue length 车辆排队长度去看说哪一种绩效指标哪一种策略最好。然后最后会借由以下这个 no 的这个绩效指标所模拟出来的东西，然后作为一个参考。然后以下是验证的部分，主要做2部分。第一个就是我们会先到路口去测1个小时，然后会手动计算说，这个计算出来的结果跟我们那1个小时里面的资料丢到模拟平台里面所得出来的这2个车辆研制的部分，然后去做个比对，然后发现说这2个绩效指标是所算出来的车辆研制指标是相同的，所以这个模拟平台是可靠率增加的。然后接下来是针对模拟结果的分析，主要有3个部分。情境设计部分 A 方案主要有这3种，第一个是轻轨班距，有6种轻轨班距，然后3种交通流量，现况的中流量跟高流量，还有优先策略这4种现况，这4个策略。然后本研究假设现况的策略是以完全优先策略，就是完全优先策略这样。然后基本的参数假设主要是车道的配置的不同，4车道汇入3车道，然后各2车道。然后 B 方案的部分也就是差在说车道配置的不同。然后接下来是情境的分析部分，主要有这3个：固定班距、固定流量和固定策略。固定班距给定现场轻轨班距是15分钟来1班，然后去看说平面的3种流量和4种策略之间的模拟的关系。第二个是固定流量，是给定现况的流量之下，去模拟说6种轻轨班距和平面的和4种策略去做模拟分析。最后固定策略是使用这4种策略，然后去做模拟。最后以上这个3个情境分析会借由2种绩效指标，车辆延伸、车辆排队长度2种指标去做衡量。最后会把 Fishing 所模拟出来的结果，会在后面进一步的结论做分析列表说明。然后以下是小结论部分，针对 A 方案固定策略下的小结论部分，可以从这张表格可以看出说，我们不管是在平面研制部分或平面排队长度部分，我们是以现况最佳的策略，所有的策略去减掉现况最佳的策略的最好的绩效值，所以可以从这边看出说，在平面研制下，以全出动策略为最佳策略，然后它缩短是1.77秒，而在排队长度部分的话，是以部分优先策略为最佳策略，这是在 A 方案就现况方案之下，而 B 方案的话，可以看出说，策略减掉现况的这策略状况之下后，都是以绝对优先策略为最佳策略。然后我最后的分析结论主要有3个部分。第一个是说我们在 A 方案中以2种绩效指标来做衡量，第一个是以车辆研制为指标，发现说是以全出动策略为最佳策略，而车辆排队长度是以部分优先策略为最佳策略。而在 B 方案中，就是干知道相差非常大的这个状况之下，以这2种绩效指标，不管是哪一种绩效指标，它出来的结果都是以绝对优先策略为最佳策略。第3个，我们也最后会有一个表格呈现给大家看，然后会呈现说，在 A 方案状况之下，干知道车道数相近的话，它的部分优先策略占整体最佳策略的52.78%，而在 B 方案下，干知道关系相差悬殊非常大的话，它的绝对优先策略占整体最佳策略的65%。然后最后整理出来这个表格，可以从整理4个表格 A 方案跟 B 方案，然后分别是不同 不同的绩效指标，一个车辆颜值，一个车辆排列长度。然后以车辆颜值来看，可以看出说轻轨的不同班区，6种不同班区和3种平面交通流量之下，它所提供的最佳策略是这样子。然后是以绝对优先，是以部分优先策略占整体的策略是最高的。然后车辆排列长度也是一样。然后接下来 B 方案部分，不同轻轨班区和不同交通流量之下，然后它所适合的策略，然后绝对优先策略占的比例是最高的。最后是我的新的分享，主要分为2部分。第一个部分说为什么会使用 Leasing 有以下几点。第一个，模拟平台它所模拟的东西可以趋近于现况，然后借此可以增加模拟的可信度。第二个，可以撰写 VAP 档，就是耗资控策略，最后也可以借由不同的绩效指标去衡量说这个策略好或坏。然后最后一个就是说 ，Leasing 的模拟软体是现今较为成熟，而且世界领先的微观模拟软体，所以故研究出来的可信度是可增加的。然后我在心得部分就是说，在模拟过程中，在验证和撰写 VAP 档是一件很难忘的一件事，因为从模式的参数的效估到验证，到最后的耗资控策略的撰写，中间修改很多次。然后我觉得印象最深刻就是说，在验证的部分要不断的去思考说哪个参数是可调整的，然后有哪些是落掉的。然后在 VAP 档撰写上面，要从口头的纸本，就是从头脑里面的纸本这样子写出来的东西，跟实际 Leasing 可接受模拟平台的这个关系中间是有一大的落差的。所以呢，我们要如何去借由说改变，或是去调整它的一些函数的定义，然后借此可以让你的模拟的策略可以更贴近现况。对，然后期间遇到很多问题，然后不但出错，也询问很多专家。然后因此在 Leasing 这块模拟软体上有初步的认识。然后未来我也期望在进一步使用 Leasing 的各种模拟软体，然后用在更多的运输领域上面。那以上是我报告，谢谢。
好，我们谢谢2位毕业生分享他们的硕士论文，就是相信就是有用 Leasing 这个东西来做硕士论文的这个成绩的话，就是他们对于 Leasing 的操作已经非常熟悉，所以听他们介绍，其实可以知道 Leasing 它能达成的功能啊，然后它有一些验证的步骤，然后有一些跑出绩效的一些分析的功能。那谢谢他们的分享，也谢谢王凯明先生分享这关于 Mobile App 的部分。那因为碍于刚刚技术上的问题，时间有点 delay， 所以Q&A 部分我们暂时取消。那如果大家有问题的话，可以利用就是剩余的时间，就是比如说茶叙的时间去做一些交流。那我们现在就进行就是午餐的部分。那午餐也是在外面有备好大家的午餐，也是buffet的形式。那请大家不要拿进来用餐，再麻烦大家，谢谢。那大家请1点半的时候回到座位上，我们进行下午的议程。